Hello and welcome to the DataPains channel. My name is Simon and I work as a lead data engineer day to day. In this video, I want to provide you a step-by-step tutorial for beginners how to run Apache Spark in Kubernetes. Apache Spark is a powerful open source distributed computing framework. And Kubernetes is a popular container orchestration platform. By following along with this guide, you will gain the skills to set up Apache Spark on Kubernetes efficiently. A good point to point out here is that Apache Spark has been supported for Kubernetes since Spark 3.1. So for quite some time now, for almost 3 years. However, there's not many people who have been running this live in production. I myself have been running Apache Spark on Kubernetes for over 2 years. So I know some of the drawbacks, pros and cons. I can't go into all of them in this video. I'm mainly focusing on showing you how to set it up, how to run it, and guide you through it step by step. So let's go. Okay, so let me try and explain how this works. So traditionally, let's say you run traditional AWS EMR. I know EMR also has a Kubernetes execution engine as well, but if you run like Spark, like you did in the, traditionally, you would spin up a cluster, and in this cluster you would obviously have your driver, and you would have a set amount of workers, or actually executors, if we want to keep it to Spark paradigm. So you would have something like this. You would then be over here as the user, and you might define, let's say, a template, of some sort for EMR, where you would say, what node type, node type X, memory, Y, CPU, Z, etc. And then this would be spawned here. This cluster would run, do its thing, back and forth, do its stuff. It would write its output, it would read, and it would write. So the other way around, so it would read and then write. So let's say, for example, let's say S3, okay? So it would do its thing here, it would push, you would be able to see the logs, and that would be it. So this is a batch job scenario. So you have something, you click it up here, and this could be stuff like Airflow, Prefect, Argo Workflow, AWS step function, manual. It could be any type of orchestration tool to trigger this. Well, when you do it this way, it means that every time you want to execute a new job, you would do something like this, where you would spin this up to the same cluster. So these would be executed towards this let's say this is EMR. So all of these would be executed to that very same cluster. However, in Spark on Kubernetes, it works slightly differently. So you have essentially the client. So in our case, this will be the Spark operator, which we will go into a bit in a while. And this one performs a Spark submit, right? And inside here, let's say this is our Kubernetes cluster. So this actually goes over here because the operator also runs in Kubernetes. So here we have a Kubernetes cluster. We do a Spark submit, and essentially in the operator, so this is the same part. So you have the API server, and you have the scheduler. So this is also the Spark operator in this case. So the Spark operator will manage the Spark submit to the API server and scheduler, which then in return will spin up a tiny cluster with a driver and an executor or several of them. You can also do auto scaling, but let's imagine this is this one. So we call this batch job A. Okay, this one will spin up. This is now its own little cluster. So this one here has its own UI. It has its own metrics. It has its own compute, so memory, CPU. It has its own node type defined. Either the one you're using default on your cluster, or potentially if you reassign it to another node group. But so the biggest difference here now is that each time this happens, so this is essentially batch job A. The beautiful thing now is, rather than having, stuff being executed to the same cluster, if I now run another one, so here now I could trigger a stream job. A stream job. And this one, this would be trying to change the text. That's really annoying. I'm just going to do it from the beginning. So this one comes here, and this is stream job A. B. Okay. And then this one runs, and it has its own metrics, its own compute, etc. So what happens here now, right, is that now you get a really nice encapsulation of the workloads. So you can run, and so essentially every single job that you submit is its own little cluster. So this is a big difference. There's obviously some drawbacks to this. So if you use like some kind of framework, or something like Apache Livy or something like that, where you're kind of submitting tasks like from a notebook, for example, to a live cluster, that doesn't really work here. But that's not really why you would run Spark on Kubernetes. You want to run Spark on Kubernetes because, due to the encapsulation, you separate concerns of different workloads and stuff like that. And this is if you run it with a Spark operator. So currently in the Spark operator, you have two types. You have Spark application, or you have Spark scheduled application, right? And if you run it with a Spark schedule application, this could be, for example, if you want this to run on a cron, but you don't necessarily really want to have an orchestration tool to manage this. So this will just utilize the vanilla underlying Kubernetes engine, and you essentially run this maybe from your CI/CD. You submit the job, it's scheduled, and then that will run on the cron basis every single time. Or you do it as a Spark application, and this could be either a stream job or a bash job. However, after each time this is done, it's gone. So this would need to be orchestrated from some other tool. So for example, me myself, I've been using Argo Workflow to submit essentially a job within a manifest, and the Spark operator picks it up. It does all this for me. Okay, so to host the Spark operator, it needs to be installed. And you can orchestrate the Spark operator vanilla style, if you like. However, here I'm going to show you how to deploy it on ArgoCD. So that requires you to first set up ArgoCD. And I'm going to link to this repository, including with a Medium post. and how to set it up. And essentially, it's just following this README. All of this will help you to spin up an ArgoCD on your local machine. You only need Docker Desktop with Kubernetes enabled. And once this is up, you're good to go. And in this README, I essentially explain what you need to do. So here I also, for demo purposes, tell you to create a namespace of Spark. And that is because as we deploy this operator, we will essentially also create some service accounts, stuff like that, which I'm not going to go into here, but essentially it's essentially like roles for the different namespaces. So now I executed this command here, make apply. So this one will just spin up my operator. And as you can see, I also have Argo Workflow already set up. So I will point that out again later on in the video. Right here, right now, I'm just gonna force sync this one so it comes up to date. But this essentially right now is syncing. This is setting up the operator. It is pretty neat. And as you can see here, we have two service accounts, one for the operator itself and one for the Spark namespace where we will be running applications later. And that's that. I think it should work, but if we go back here, so now everything's fine. So now this is up and running. And essentially, this is now ready for us to do Spark submits too. So we define the job, which and we run it towards a Spark namespace. The Spark operator will pick up the Spark application and do whatever it's meant to do, either if it's going to execute immediately or if it's a cron. We're going to not use a cron because we're going to use Argo Workflow to manage the cron workflow for us. But in the code for the operator, it is very straightforward. It's using everything's open source. So you can go and find my structure here. We just go and we fetch the official one. Here I'm using the version 1.4.3, which at the time is the latest. And here you can see I'm just specifying what it needs to do. So this is utilizing the official Helm chart of Kubeflow Spark operator. So this is great. Let's move on to the next step. Okay, so now we're going to go and we're going to look at the Spark example. So we now have the operator up, but to be able to submit any jobs for the operator to pick up, we need to have a code structure, essentially an image, which has all the entry point scripts, etc., that will make sure that this works. Because the operator, it will be able to spin up the driver, but we need the workers to connect, or executors, sorry, to connect to the driver. And to do this, we need to tell it how to do that. So the Spark operator will only really manage the driver, and obviously it will see the state of it. It will be able to follow the executors and see what's going on, but ultimately the driver is what's responsible for spinning up executors. So we have operator spins up driver, driver spins up executors, operator sees state, and either it completes or it fails, etc. So I have this repository here where we set this up. So it's pretty straightforward. This README tells you everything. Here I'm running with the absolute latest Spark. I even added Delta, the latest Delta version. So currently for the demo, we don't really use Delta, but I was thinking of using it later on since it has quite a lot of cool new features. So feel free to use this. It's essentially a Java 17 based image that sets up a Python 3.9 in a poetry environment together with the latest Spark 4.0 and the Delta. And here I also have an example of how to run this locally when you build this image, and how you can execute yourself into it and use it. I also link here to the Argo Workflow that I'm going to show you shortly, where we utilize this. The important thing here now is that I've already built this image, but essentially it's as easy as just doing a make command, and you're good to go. And the actual Docker file you can find here. And here I explicitly download a lot of the jar files and I organize it to make it work. So this I've added a link here to how I set it up, and essentially with the latest Delta, it tells you what dependencies you should have and what it comes with, etc. And this stuff can be a bit fiddly to manage yourself, but it's not difficult. You just need to know how to go about it. And the important thing here is that we also use Poetry, which is pretty cool, and it's being installed on the fly here. It's utilizing the toml here. So in the toml we have set up the different Python environments we should use. And the most important thing are the scripts. So most importantly, the entrypoint script. And inside this entrypoint script, I found this originally from the open source data mechanics Docker image. I've done some slight modification to this though, since I'm setting up the Poetry environment here. And I do that in the beginning. So this means that you can run this image with different Poetry environments if you like. You can try out different Python versions, etc. But again, here it's explicitly 3.9. And in this script, essentially, it just goes through and it makes sure that all the paths and environments are set in the right way. And then essentially the most important part is here. So in the first case, this is when we do a Spark submit, as you can see here, and essentially this will make sure that the driver is binded to the executor. And this way, it will always work. So you don't have to worry about it, which is great. And also, if you don't run a Spark submit, you override the entry point, which is in the image. You can go in and investigate it and have a look yourself, just as I show you in the README. So now, when this image is up and running, we need to essentially create our actual Spark job where we utilize this. So let's jump straight into that. Okay, so now when we have ArgoCD up and running, we have the operator up and running, we have the Spark Docker image we're going to use to run this. We are going to orchestrate this through Argo Workflow. So we need to set that up. So in this repository, there's two ways of deploying this, either vanilla style, not through ArgoCD, or through ArgoCD. So I'm going to highlight to you the option of running this through ArgoCD so we can see the actual Argo Workflow deployment and manage it properly. So the first thing we do here in this repository is we don't necessarily need to care about this part of the README, but we will care about this part. But that will come at a later stage. The first thing we need to do is essentially in this repository to set up Argo Workflow itself. There is a big deployment file here in right now, which is quite messy. So the main reason I do this, normally I would split up all the different kinds into their own things, have them in their own files here, etc. Easy to manage. However, for demo purposes, I've just gone to the official Argo Workflow documentation. I've templated out a very small, a deployment of Argo Workflow. And the thing here is that they do have a Helm chart. The Helm chart for Argo Workflow does not seem to be as mature as for ArgoCD. So we have a few problems here. When we run Spark, the Spark operator in ArgoCD, we then spin up Argo Workflow. Argo Workflow needs to be able to spin up the job to the Spark operator namespace and access pods in the Spark namespace, because it first submits the job to the Spark operator, then the Spark operator spins up a job in the Spark namespace, and then Argo Workflow needs to be able to see what's going on in the Spark namespace, because we're going to deploy this in something called manifest. So to do that, you need to link roles to the Argo Workflow service account role. And I tried doing this in the Helm chart. They were pointing out in a few places where you can do this. It just did not work at all. I could not get it working. So I went down and did vanilla style. So in this file, if you search, you can find this. So essentially here, I just make sure that I provide the right of this role to access the API group of Spark Operator. So by doing this, I'm giving it access to the Spark Operator. Spark Operator has access to the Spark namespace, etc., and then everything works. So that could probably be a video by itself, which I'm not going to go too deeply into. But anyway, so that's that. It's here. I've done it for you. So, you can use that as a baseline and do whatever you want with it. You can improve it. You can try to go and use the Helm chart, because what I'm going to show you will work as well. You might need to modify slightly. But anyway, there it is. So now actually we want to run this through ArgoCD. So we go back to the ArgoCD repo. And in the ArgoCD repository, we need to essentially now set up a secret. So you need to follow this. You need to essentially create a fork of my repo, or of some kind, and you then need to link that to this, because essentially ArgoCD is gonna sync from this repo and see what's going on. So that's why we do that. Then we run this command, and this will spin up Argo Workflow. So if I go to the actual Argo Workflow now, to applications, yeah. So now you can see this is up and running. So this is good, perfect. So now we can do stuff, and let's talk about that in the next step. Okay, so now when the Argo Workflow deployment is up and running and managed by ArgoCD, we're now going to access the UI of Argo Workflow. So head back to the Argo Workflow repository, and for now, we're just going to do a port forward. So now we're going to port forward this. So here you can see that yeah. So here we have the workflow. And here we have ArgoCD. So everything's up and running. Let's now head back to the UI. So I'm going to head out to the Argo Workflow. So here now, we can see that there's nothing here. Perfect. And I'm now going to show you how we submit our cron, and we take it from there. The layout of how this is submitted. So inside Argo Workflow, right, we have our workflows, and we can go to the Spark example, and we can go into the template, and here we have essentially a small DAG that will do this for us, and the actual Spark job is here. So as you can see here, it runs within the manifest. It's pretty straightforward, and we do some checks here if it completed or if it failed or not. And this Spark application is essentially a custom resource definition, or what's called a CRD. So this is what they do for us in the Spark operator, so we can then just pass on these things. So here you can see I'm using the image. I'm telling it to never pull because I'm using Docker Desktop locally. I put some other configuration, and we're ready to go, really. And here I'm just doing a very dumb print success. And then here I have my actual DAG where I run this. So this is all YAML defined. You can run this one by itself if you like, or whatever. I just want to show, and compared to like Argo, compared to something like Apache Airflow, this is much easier. There is no code at all. You have your code bases elsewhere, and here you just define YAML to run stuff. And if you have a lot of workflows running, you don't need to build one monster DAG. You can have a lot of independent, smaller DAGs, and you can design your pipelines to be more incremental and stateless, etc. So yeah, so let's now apply this. Okay, so in the Argo Workflow repo, in the README, we have essentially the command that we need to run to do this. So we're going to take this, make deploy Spark chart. We can run it, and right now I already ran it before, so I'm just going to update to see, so you can see that it works. Okay, great. So now this has been submitted. So now we can go and check this job. So as you can see here, this one runs every 15 minutes. So I don't really want to wait 15 minutes. So I'm just going to go here and submit it. And now this is running. So we can go here, and I will show you how the logs look like on all ends. But this one ran pretty quickly. So here you can see it went in, it checked what was going on, and it associated this as true. So the Spark job completed. And here I'm just running a dumb print like success, and then it's visible like this. And then now this will continue to run automatically. So let's go and just have a look a little bit under the hood on this actual Spark job. Okay, so we just saw the job run, right? So if I do, I can see the actual under the hood pod that was running. So if I do kubectl get logs, so here essentially I can see that the Spark job executed. So this one ran, and it ran with one executor. We didn't see that, but essentially it spawned up a driver, and then it requested a worker executor. Sorry. So if you look here, executor. So here you can see that default mode, executor resources. Here using initial executor 1. So here essentially we ran a very, very tiny distributed application, one driver, one executor. The executor did register, so it became available. It then read some dummy data, some unstructured dummy data. It then took that data and kind of put it into a kind of map format, key value, and then we did some basic denormalization, and then that's what we printed out, and that's what it was, and that was the whole thing, and nothing more to it. And if we go and we should check on the Spark operator, we can see here that it when it submitted a job, and here it essentially ran through, it ran the submit, it smacked through this whole thing, and here you can see that, okay, submitted, it runs through, okay, now it's saying, okay, it's running. So here you can see that the Spark operator API is checking the state of what's going on, and here you can see also the executor state. So the operator checks the driver spins up its own executors. The operator can still, though, get some response from the driver to see what's going on. And here we get to what I talked about in the beginning of the video. We get every job is its own little cluster, and it's all encapsulated, and it's quite nice. And then this runs for a while, all the way until it comes down to completed, and then it's done, and that's it. So I hope you like this video. If you, I would highly appreciate if you like, comment, and subscribe. And I wish you a great day, and I see you next Sunday.